Okay, so some other things when we start talking about sine, cosine, tangent. After you put them into your calculator, if you have sine of a degree, it has to be 1. Actually, it's going to be less than 1. So sine of whatever degree will always be less than 1. Cosine of something will always be less than 1. If it's ever 1 or bigger, something is wrong. Okay? Mainly because you're always going to have the adjacent over the hypotenuse, opposite over the hypotenuse. If your hypotenuse is ever bigger than this one, or sorry, if this one is ever bigger than the hypotenuse, something's screwed up. Okay? So just so little things that you're putting in, if you ever get an answer that is bigger than 1 for sine or cosine, double check your math, double check you put it in right. Okay? So as long as everybody saw where that stuff is on their calculator, I'm going to go on to kind of the lesson portion of it. We'll do some practice, and then it'll all hopefully make sense. All right, so for my very first example here, I've got this triangle. It's got 25 degrees. I've got 18 on one side. I've got x on the other side. So the very first thing that I'm going to do before I even try to figure out which one these ones are, I'm going to identify the information that I do know and that I want to find out. So here's the degree. So 25 is the degree based on this degree right here. I'm going to give these ones names. So 18, that one is going to be adjacent to that angle. So that one's adjacent. It wants me to find x. X is opposite of that angle. Okay, I'm not going to write down hypotenuse. I don't want to have one extra word to screw me up. I'm only going to write down the information that I have and that I want to find out. So they give me the adjacent. I want to find the opposite. And then I have the angle. Looking at either your note card or my sheet that's on the board, which one of those, sine, cosine, or tangent, deals with adjacent and opposites? Tangent, perfect. So tangent has opposites and adjacent. So I know for a fact I'm going to use this equation, the tangent equation. So when I write it, it is going to be tangent. So TAN, the number that comes directly after tangent is going to be the degrees, and it has to be degrees. So tangent of 25 equals my opposite over my adjacent. So the number that, or what they had for the opposite was the letter x. What they had for the adjacent was the number 18. So I get tangent of 25 equals x over 18. Okay? Opposite over adjacent. Now, for me to solve this, I want to get the letter x on a side all by itself. So right now it's x divided by 18. So I want to do the opposite to get x all by itself. What's the opposite of dividing by 18? Multiplying by 18. So I'm going to multiply both sides by 18. Okay? So if I multiply both sides by 18, these ones cancel out. And I'm left with 18 times the tangent of 25. So as I put it into my calculator, I'm going to write in 18 times. As long as, Jesse, ignore me. As long as you only put this part in parentheses, you're good. So you can put 18 times tangent and then 25. That part needs to be in parentheses. Okay? Okay, when you got done doing that, so for everybody else kind of follows that rule. Jesse, for you, you're going to do tangent of 25 times 18. You just have to work backwards because that calculator is not smart enough to do it. Okay? So hopefully, when you got done working this one, you should have had x equals 8.39. When we get to the assignment, you can do it to the nearest 10. So if you had 8.4, that was good. So the length of this side, the length of this one over here is going to be 8.39, or I could say 8.4. Again, the biggest part that I'm going to stress, put down my labels, so I can figure out if I'm going to use sine, cosine, tangent, and then plug the information in to an equation, so that way I know if I'll have to divide, multiply, whatever to get x by itself. All right, example number 2. So I'm starting off with this one. I have 70 degrees here. I'm going to identify the numbers that are next to it. Hopefully with your help. X, what's that one considered? Fantastic. X is going to be the hypotenuse. What's 15? Adjacent. Awesome. Out of all of these choices, which one has adjacent to hypotenuse? Cosine. So as I write that equation, it's going to be cosine of the degree, so of 70 degrees, equals the adjacent over the hypotenuse. So equals 15 over x. Okay, let me grab a different color. So I've got cosine of 70 equals 15 over x. I want to get the x on a side all by itself. Okay, currently it's on the bottom of a fraction. I can't do that. So I'm going to multiply both sides by x. Oops. So I get x times cosine 70 equals 15, because those ones canceled out. Canceled out, canceled out. And then the very last step I'm going to do is I'm going to divide both sides by cosine of 70. So my answer on this one is going to be x equals 15 divided by cosine 70. Go ahead and punch that one in the calculator, see if you can work through that one. I'll turn up the lights, that way if you need solar power, you can do it. Hopefully, you should have had about 43.86. Anybody have something way different than 83.46, or sorry, 43.86?
You said it always has to be under 1. Is that for when it's just like basic one?
So this number, so like when you punch this in, so like I'm gonna say again, I'm using Jesse's calculator here. If you just did cosine 70 just by itself before you multiply anything else, that was gonna be, what was it?
You can just get like solve for cosine of 70 and then do 15 over whatever.
Yeah. So like if you would have just done this one and changed to a decimal first, it would have been 0.342.
So 15 divided by.
Well, 0.34. Yeah. Okay. For like if you have a calculator that does not want to work with you, sometimes you'll need to write down the decimal beforehand. Make sure you put down at least 2 decimal points. Okay. What I want you guys to do is, this one's going to be on your own. I want to make sure you guys have this one. I'm going to identify the things with you, and then I want you to solve this on your own. Again, I've got 7 degrees here. The 5, what's that one going to be? Hypotenuse. And then what is the y? Perfect. Go ahead and solve it. Figure out which one to use, and then solve it. Yes. You got it? No. So write it out. Don't try to do it all on your calculator. Show the steps. Yes, ma'am.
Huh? Also, I'm gonna do one tomorrow.
You did it right. Okay.
Oh, did I?
We're gonna talk about depression.
Just you're so good.
Did I actually? You should.
Angle.
I was like, this is not class. Okay.
No, I'm just kidding. Because I don't know what's going on.
Yes, ma'am.
Don't listen to me.
Okay. Yes, it is.
You
You did fine.
would.
Nothing but the degree. It automatically is.
All right, so
Yep. Automatically degrees.
you have seven, right? Equals 7 over 5, right? How do you know? And I'm like, I think I just saw that. Why is cancel out? So then you have, how do you know that's the sign of 7, right? And you multiply that by 5.
Is that
You know what I'm trying to say? Just. The one that's landed. No,
Perfect. That's right.
because like the angle could be the one that like the top left, and the opposite would be that's.
The hypotenuse is the one that's like across from the square.
Wow, I think wrong. You're so smart.
All right. Hopefully, when you set it up, I'm going to go over this one with you. You should have figured out that you were going to use sine for this one. So you should have had sine of 7 degrees equals the opposite, which was y, over the hypotenuse, which was 5. So to get rid of it, it would have been 5 times the sine of 7 equals y. You should have ended up with y equaling 0.609 with some other numbers. Okay? So far, so okay? Okay. So up until this point, there's one more part that I'm going to go over with you. Okay? Don't worry about writing this down. Don't worry about writing it down. It should hopefully make sense. What we've been doing is they gave us one side, they gave us one angle, and we had to figure out the other side. Sometimes they will give us multiple sides, but they will not give us the angle, which is exactly what you guys did on your assignment yesterday, or the one that was due today. So the assignment from yesterday, you guys were able to figure out like sine of letter A or letter B, whatever, equaled a decimal, right? So in order for us to solve those ones, we have to use the inverse of sine, which I'm going to show you on the first example. Hopefully it'll make a little more sense when I explain it that way. But we're going to be doing the inverse of sine or inverse of cosine, inverse of tangent. The way for you to get to that on your calculator, depending on which calculator you have, most of you guys, it'll be like the second button. So you'll have a little second on the very top, left, top, right, whatever. And then above sine, cosine, or tangent, you'll see the sine, cosine, or tangent with like a -1. You see that? That's the inverse button. Okay? And then with the inverse button, then you'll put in either a decimal or kind of that fraction sort of thing, depending on your the set of parentheses. This first one hopefully will make a lot more sense when I explain it. I'm not going to get into the details of it because you guys did this a ton yesterday. So I'm just going to skim over really quick. It says it wants me to find the measure of angle A. So I'm looking at this one right here. This one is going to be adjacent. This one over here is going to be opposite. So I know that I have the opposite, I have the adjacent. The one I'm going to use is going to be tangent. So the way I write it will be tangent of A, and I don't know what A is, equals my opposite over adjacent, so 6 over 20. So what you guys did yesterday is you did that 6 divided by 20. Stop it. So let me get there so I can get back to writing it. Come on, calculator. 6 divided by 20. I get 0.3. So I have tangent of A equals 0.3. Okay? Well, the problem is I want to get A all by itself. In order for me to get A all by itself, I would have to divide it by tangent, which is really, really weird because I don't really have a number for that. So like essentially I'm just dividing this by tangent, I'm dividing this by tangent, which seems awfully confusing. So instead of dividing it by that, our calculators have a real fancy button that allows us to do that. When we have something that looks like this, like tangent of A equals 0.3, in our calculator, what we can do is A equals the inverse times 0.3. So the stuff that you guys all did yesterday, what you had in decimals, you're going to write it as tangent, like the second power or whatever, and then you're going to input that number. So tangent of -3, or sorry, inverse tangent of 0.3. Yeah, 16.699 or 16.7. Okay, so for that one, A is going to equal 16.7. I'll do that one. Hopefully made sense? Okay, second one I'm going to do quick, and the third one you're going to be on your own. So same thing. It wants me to find angle A. So I'm going to go through. I'm going to identify what I do know. 15 is my hypotenuse. Perfect. 3 is adjacent. Looking at this, which one has the adjacent and the hypotenuse? Cosine. So when I write it, it'll be cosine of A equals my adjacent, which is 3, over my hypotenuse, which is 15. So cosine of A equals 3 divided by 15 is 0.2. And then I'm just going to do the inverse function for cosine, 0.2. So hopefully when you did the inverse function of cosine and 0.2, you were left with 78.5. You guys feeling good? Last one on your own. Right there. It wants me to find angle P. So I'll go with you. What's 19? Perfect. What's 13? Perfect. Make it happen. You're fine. Yeah, trying to find angle P. Yep. Oh, I cleaned it. Yes.
It was, yeah, I wrote it.
Your desk, okay.
Is that a 75?
Oh, yes. You round one decimal place?
Yeah.
Okay, then I'm going to talk that in a second too. But yes.
Yeah, it's a habit.
Look.
Sure this is right.
No, you did say.
No, it's 47. Oh.
No.
What
It has to be cosine.
How do you? Oh.
Yes.
Wait, I'm thinking.
Wait. Is this?
Yes.
What did you say?
Yes.
Oh, I get it now.
Okay. I see a lot of them and I like it. I'm going to show you 3 separate things on this one. Okay, you guys all did it right. You guys all had it correct, and I wanted to show you kind of the differences between the 3 different ways to do it. So you guys all did cosine of P equaled 13 over 19. You guys all did that one fantastic. Some of you guys did cosine of P, and that equaled, let me write down the different ways you guys had it. Some of you guys wrote it as equals 0.7. Some of you wrote it as cosine of P equaled 0.68. Some of you guys wrote it as cosine of P equaled, I'm just going to put it as parentheses, 13 over 9, meaning it's going to be the exact number. For you who did 0.7, what'd you get for 0.7? 45.6 degrees. Okay? If you did 0.68, what'd you get? 47.2 degrees. And then if I went with the exact answer, it was 46.826. If you kind of notice this, depending on where you rounded, we had kind of a difference of almost 2 degrees. So when you do this, make sure you are using 2 decimal places, at least 2 decimal places, and make sure you're rounding it correctly. Some of you guys, you just saw the 0.6 and you rounded it down to 0.6. I think there's a couple of you guys that had like 44 or something like that. Okay, so make sure if you're going to round it, 2 decimal places, 0.46. Sorry, 0.68. Otherwise, you can leave it as a fraction and put it inside parentheses, and that works as well. Any questions on that stuff?
So basically, everybody's gonna get like different answers, but as long as we're.
As long as you're within, it should be within like a degree and a half.
Should we just leave it as the exact number?
If you want to leave it as the exact number, yeah, that's fine. Okay, your assignment then, it's a worksheet. The worksheet itself, I'm going to hand it, so I'll wait till everybody gets it, and then I will explain it. I think I gave you 2 minutes, my best. One, and then, okay, for numbers, and again, when I just made the copy of this, I didn't erase like numbers 1 and 2, that's why it starts on number 3, not bad. Numbers 3 through 8, you're just going to put those in the calculator. That's all you're doing, just punch in the calculator. Numbers 9 through 11, those are the ones that we did in the first half of the lesson today. Numbers 12 through 14, that's what we finished off the day with. So numbers 9 through 11 will be like regular sine, cosine, tangent. Number 12, 13, and 14, those will be the inverse. Sine, inverse, cosine, inverse, tangent. Okay?